We did about Newton's second law of motion, and also we can remember we learned about Newton's law. But Newton is some sort of scientist whom introduced, not actually not who, not I'm not going to tell that this is coming from Newton, but there is some important things we should know when we are living on Earth, because you know that we all are considering about gravitational force. You know that gravitational waves and those new kind of scientific explanations are not going to considering in Newtonian physics, because you know that there are two kind of physics in world, not yeah, in world, because the first thing is Newtonian physics, Newtonian physics, and now we are going in the certain time, or the this time, or this, in this situation or in this period, uh, most of the scientists are interested in quantum physics, not in Newtonian physics. But we know that all the old innovations up to now, most of the new innovations up to now are going with Newtonian physics, not with quantum physics. There are very few number of innovations we can see which are using quantum physics. Most of them are using Newtonian physics. Newtonian physics. So I think it will be beneficial if we can learn about Newton's another thing, or other than that, it will be better if we can consider about gravitational force. I will explain it in an easy way, but before all of those things I need to write another equation. It will be just like F equals to capital G m1 m2 divided by r squared. So Newton said that if there are two particles, or two, actually these are coming for not for masses, not are particles, these are coming for planets, but here I am considering about only very small particles, and the distance between the, between the center of gravity of those air particles will be same, because there are no radius which we can consider, because we are consider about only particles have no radius, it's only a pointed mass. So here we are considering about pointed masses. M1 is a pointed mass and also M2 is a pointed mass. So if I consider about the distance between the two pointed masses, actually I am considering the distance between those center of gravities of those pointed masses as r. So Newton saying that F is directly proportional to m1 into m2, and also Newton saying that F is indirectly proportional to r squared. F is directly proportional to m1 into m2, and also F is indirectly proportional to r squared. We can write indirect by this way, 1 over r squared. It is the way to show the indirect proportional. So here we can see this is 1, and we can take this is as the second one. So using first and second, we can write F is directly proportional to m1 into m2 divided by r squared. As I mentioned before, if we are eliminating this directly proportional sign, we need to come up with an equal sign with the constant. So this time this constant will be g. So m1 divided by m2, sorry, m1 into m2 r squared remain unchanged. So f is equals to g m1 m2 divided by r squared. This g can be traces as gravitational universal gravitational constant. Universal gravitational constant. So actually now we are considering about gravitational force. So what is this? This is gravitational force. Gravitational force is equals to g m1 m2 divided by r squared. G is universal gravitational constant. Okay, alright. If we know about universal gravitational constant, it will be better. Right.